Hi, everyone. My name's Rob Kaplow. I'm a software engineer at Google, and I'm here to present an introduction to Chromium metrics. Before I get started, everyone who's on the live stream, I want to thank you for coming to me and Tim's talk over Vint Cerf, who's presenting it the next time. It's a real honor. So this presentation is going to be covering Chromium metrics. I'm going to be talking about the different parts of the Chromium data collection infrastructure and how we use it to make Chromium-derived browsers, including Chrome in particular, a better browser for our users. So Chromium is a very complex piece of software. There's millions of lines of code. There's billions of users all around the world, and used by many different types of people. And on top of that, there's really a lot of additional complexities. It's used on many different types of devices and operating systems. And the software itself is used in many different ways. Sometimes just as sort of a classic browser, but it also gets used in other ways as well. And because of the scale of the complexity there, the impact of changes aren't always the most intuitive. So a developer may make some changes in the software that you may have some expectations of what it's going to do, but sometimes it may not do exactly what we do. And so because of this complexity, it's really important to be using metrics thoughtfully. Chrome in particular, we really strive to do data-informed decision making. This means we don't just make decisions based off kind of gut feelings. We really try to look at the data as much as possible, early on in the process, late in the process, all throughout the process. And it's really a critical part of our engineering and product culture. Metrics help us make these better decisions. They improve our intuition and understanding of the ecosystem, how users are using the browser and how the browser interacts with everything else. And as well, very directly helps us measure the impact of the changes we're making. Just in very general terms, how do we use client metrics? First, we use it to track progress of our goals. Are we growing usage overall and users? Are the features that we're building as part of the software being adopted? Next are just helping us decide what to ship. So maybe a feature is being used, but is the feature working correctly? Is it having the expected effect? And are there particular variants that work best? Maybe there's a few different ways you could tweak a feature, and the data helps us decide which exact version we want to ship. And this list isn't covering everything, but a third and very, very important one is general monitoring of product health. We have a wide set of metrics that we're looking at all the time to make sure that the browser and software is working as we expected. And we're always checking these metrics to see if there's any regressions. For example, we have metrics tracking how long browsers take to start, how fast pages load, and if our users are crashing. So these types of metrics are critical for us to be looking all the time across all the channels. And this really is the most important thing to make sure the product health is kept high. So this talk is just an introductory talk. I'm really just trying to get you familiar with some of the real basics of working with Chromium metrics. Obviously, there's lots I can't cover just in one talk. The focus of this talk is really how we use metrics in product development. Some of the data collection details itself, and specifics on how to add new client metrics. Of course, there's lots more to the story there. For example, analysis, where you actually take the data and use it to drive decisions. That's a very long, complicated topic that isn't going to be really covered in this talk. So it's an overview for the rest of the talk. There's going to be three main components. First, I'm going to talk about in the product lifecycle, when do we look at metrics? Next, an overview of where the data comes from. And then finally, I'm going into a bit of a deeper dive into how to add a histogram in Chromium. This is sort of our basic building block of adding a new metric. So first, the life cycle of a feature. I'm going to talk about how metrics fit into the different stages of a feature's life cycle. So here, you have an overview of adding a new feature from the idea through design, implementation, experimentation, launch, and monitoring. And the question is, these different parts of the stage of the features stages, which is the most important to be being really thoughtful and looking at metrics? Is it early on is the most important, or is it only later on is the most important? So I'm here to say, we really strongly feel that looking and using metrics at every single stage is critical. And so here I'm giving an overview on, for each stage, how metrics get used. So at the very beginning, at the idea stage, um, metrics can be very useful for helping coming up with the idea and inform you, of the background of the feature and what pain points users are occurring. You looking at the data and understanding, there's this particular pain point or this is where errors are occurring can help us actually understand and prioritize the importance of different feature work. Um, it helps explain, like, is this feature even worth doing? For example, if maybe not that many people are doing this type of thing, it isn't high priority. Or on the other side, you may be looking at the data and be surprised by the amount of users who are actually using this feature, or perhaps going down this code path that really optimizing this and making it really good is worthwhile. So next, the design. When you're designing a feature, you should consider very early on what success means and make sure you can measure it so the feature can be correctly evaluated. If the design has no clear way of how to measure success, that's a signal something may be very wrong with the design. And perhaps you should be rethinking on the design of the software itself to make sure there's a clear way you can understand if the feature is a success. I also want to mention a little bit about regression metrics. By this, I sort of mean a metric which you can compare important statistics before and after the feature. Say, for example, you may have a feature where you may expect it to improve page load performance. Pages will load faster. If that's the case, it's very important to have high quality metrics related to that, and think of them as regression metrics. So you want to be able to look at the data beforehand, so you can compare what the quality of the metric is after you've launched your feature. So implementation, and to get a little bit more specific here, they really should be one of the first things you implement. Like in what I just mentioned in the design phase, if you're trying to improve page load performance, it's very important to have a high quality regression metric. If you don't have one yet, you should actually implement it ahead of time. And this way you can actually collect data from before the metric is launched, but from before the feature is launched. This way you actually have a fair set of data to use as a baseline. Next, the experimentation phase. This is one of the important things we use to make sure we can correctly measure what effect the feature has. In Chromium, there's a service called Variations, which allows you to run experiments that roll out the features to different subsets of the populations using server-side configurations. And this lets us compare the data we get. So often this will be a simple A/B experiment. What this means is this lets you directly compare the metrics of the data with the feature. That you can think of that as your experiment group, with the data without the feature. That's the control. So your control group basically is what the code path would have been even without the feature. But now you can directly compare it to the data and the metrics once you have your feature enabled. In some more complicated cases, you may want to experiment with different options or parameters to select the best one. So say your feature may be parameterized in some way. You may want to compare the control group to multiple arms, say 4 different groups of the feature enabled, each with a different parameter setting. And then you can compare each of those to each other and against the control. Next, launch. So once you've evaluated the feature on smaller channels, such as Canary, Dev, and Beta, and you've been properly cleared for launch, you can now enable the feature on the stable channel. This is, of course, a very critical time to be looking at metrics. You want to be paying very close attention to both your success metrics and the regression metrics at this point. Make sure things are going as expected, so you have a chance to stop the launch, for example, if things are not working as you expected. And at that point, you've launched, and you may expect you're done, right? Well, no, there's still more to do in terms of metrics. You should be doing ongoing monitoring. So you may have launched the feature, but you want to make sure things don't regress later. It's possible things may look very good at launch time, but then there may be surprising things that happen later. We recommend using automatic alerting on these metrics, so you can be triggered automatically if there's any regressions. And there's no particular set time period for the amount of time you should be monitoring, but we honestly recommend as long as possible. And as long as a feature is being used and is critical, you should have some monitoring metrics around them. So that's an overview of sort of the life cycle of a feature and how we use the metrics to monitor it. Next, I'm going to talk a little bit about where the data comes from. And by this, I mean a little bit more concretely, what are the different metric infrastructures we support in Chromium. Before I get into too much detail, I want a little talk about user data in general. So we remember, user data comes from people, and people care very deeply about privacy. It's very important to any software, and hopefully important to all developers here, to be very respectful of data collection. We have to be very thoughtful on the types of data we collect and how people enable and disable this collection, and making sure that part is all very intuitive, very understandable, and how we use that data. If you're ever unsure, uncomfortable with the data collection, please contact the privacy team that works with you in your browser to make sure you think everything is done correctly. So I'm going to talk a little bit some of the data sources that exist within Chromium. The first one is UMA, User Metrics Analysis. This is a pseudonymous metrics infrastructure. So by I mean pseudonymous, it has a identifier that's tiable with the installation of the browser itself. It's not tiable with any other identifier. This data collection has metric infrastructure has lots of different metrics, over 40,000 unique metrics, and these cover a very wide range of things within this very complex piece of software. Related to all the different features of it, the performance, stability metrics, and many other metrics. Another metrics infrastructure we use is UKM, or URL keyed metrics. This is a separate metrics infrastructure. It's also pseudonymous, but it has a different identifier. And it's similar in some ways to UMA, but it has metrics tied with URLs. So you can actually get information, for a given URL, this is the metrics related to this particular feature, or, for example, page load time. And this is, very useful if you're trying to, understand deeper connections between the browser and the web ecosystem overall, and can, help teams understand performance improvements and metric improvement, feature improvements. Next, I want to talk a little bit more about what it called variations. Internally to Google, we call that Finch. And this is an A/B experimentation platform. So this isn't a data collection system per se, but it integrates both with UMA and UKM. So when you launch a feature and you're experimenting on it, as I described before, you may have a few different variants that you're testing. The variance that a user is in is tagged in the UMA and UKM data. In this way, on the analysis side, we can determine which variant is performing better. So now I'm going to do a little bit of a deeper dive and describe how we actually add a UMA histogram, which is the most common metric type within Chromium. So, as I mentioned previously, there's tens of thousands of these that already exist. And so what I mean by histogram. So just think of it as a generic data structure that we use to record information about a wide variety of different metric types. On the left, you see I have a sort of the actual protocol buffer description of the structure. If you're not familiar with protocol buffers, it doesn't really matter. It's just an easy way to sort of encode data. And you can see this looks like sort of the typical mathematical structure of a histogram. We have a name for the histogram. We have a repeated set of buckets, and the buckets themselves have mins, maxes, and counts. And so even though this looks like the mathematical histogram, I'm going to talk a little bit later how the data itself does not necessarily need to be numeric, although a lot of numerics are recorded as histograms. We found this structure to be very useful and flexible in terms of supporting many different types of things we may want to record. So the way it actually ends up being is a user, emits a metric. You find out which bucket that emission goes in, and that will increment the count of that by 1. It's inclusive of the min and exclusive of the max. So this is just one data structure we have in Chromium. There are other data types within UMA that are a bit more specialized, and there's different structures as well in UKM. But for the focus on this talk, since UMA histograms is so broadly used and useful, that will be the primary focus here. So first, just some general design principles of UMA histograms. First, we recommend you measure exactly what you're interested in, as opposed to trying to compose it later of different metrics. So for example, say you're already measuring A and B, and you want to measure C, which is just A plus B in some generic way. We actually recommend you don't attempt to do that, and you just measure C directly. There's some flaws with the approach of just trying to compute it afterwards. For example, if some users never hit B, then you'll have some very biased data there. As well, histograms are not precise from the bucketing I previously described. So the values you get for C will actually be lower quality if you're trying to compose them from 2 previously bucketized values. Next, I want to mention we recommend strongly that you emit once. So this means you have a single place in the code where a metric can be emitted from. This makes it much more easier to understand. If there's multiple places a metric can get emitted from, then it's hard to know when there's a change that's occurring, where exactly in the code base this is originally from. For example, maybe that you see a regression in the metric, but it actually isn't really regression. Perhaps it's just one of the two code paths starts occurring much more frequently, and maybe that code path has sort of a different distribution. Because this is what we call a mix shift effect, and we can't really know what's happening if you're recording these two things separately. And I want to mention, so like I alluded to before, you can have metrics which are numeric and enumerated. So a numeric metric will be when you're recording some numeric value in a histogram, for example, just a generic count or amount of time. And this sort of fits the kind of the mathematical model of a histogram where the mins and max are precisely these values. An enumerated histogram is where you're recording something that isn't a numeric value. Generally, the way it works is it's sort of one of n different options, and the buckets ranges themselves don't have sort of the numeric value doesn't have any meaning. It's just there'll be a range of 1, and sort of 0 to 1 has some meaning, 1 to 2 has some other meaning, etc. And I'm going to show you an example of that in a little bit that'll make that a bit more clear. So first, numeric metrics. We have several built-in defaults, functions and macros for generic counts, but also times, which is very common. You want to say how long something takes to occur, or amount of memory. One decision you have to make when designing a numeric metric, if you want it to be the default exponential or linear. We generally recommend exponential. This means the buckets will get larger and larger as the values get higher. This is actually pretty useful because as values get higher, once we're in like the thousands of milliseconds, you generally don't need super low granularity. It's actually better to have wider buckets. This lets you capture the data with a bit better. However, in some cases, you may want the bucket sizes to be linear, which means every bucket is the same width. So for example, if you're trying to capture a percentage between 0 and 100, we generally recommend linear because you actually do care about the differences between 97, 98% just as much as you care about 2 to 3%. Next, I wanted to note you should be thoughtful on the correct choice of the maximum value of the numeric histogram. The value of the value of the max has a big role in sort of where the buckets are, and an incorrect choice of max can make the quality of your data much worse. For example, if there's something that occurs that generally takes around 100 milliseconds or so to occur, but you set the max value very high, say 100,000 milliseconds, almost all your data will be in a few buckets very early on, which makes the quality of your data much worse. On the other side, you can make a mistake if you set your max value too low, and then you have too much data above the max value. Any data emitted above the max value just falls into an overflow bucket, and this means we have no idea exactly where it is above that overflow value. We generally recommend you try to have less than 1% of data above the overflow, and even that's a bit high. We generally recommend even ideally less than that. So thinking of what's a good max value where basically almost no one should hit that, but maybe it could occur once in a while, that's a good intuition. And the max value can't be changed. If you want to change it, you would have to redesign the histogram and make a new one. Next, I want to talk a little bit more details about enumerated histograms. So let me just give a more practical example. Imagine you're trying to understand how people open new tabs. You can create a histogram called tab.newTab, where each bucket relates to how the tab was opened. For example, the first bucket may be pressing the plus button on the toolbar. The next might be opening it from the menu, etc. So an ideal design of a enumerated histogram is where it's emitted just once, and it is choice of n different options. So in the example I gave, if you just count the total count across all the buckets, this is just how many tabs are opened. And if you look at the percentage for each bucket, it's just the percentage of time it was opened in this fashion. Enumerated options should be a pretty small list, less than 100 is our recommendation. And you can append to this, but you can't rearrange it in any way because that'll sort of mix up with older data. If you want to emit something that you want much more than 100 different options, that may be a clue that an enumerated UMA histogram is not the right approach, and you can talk to your metrics team to understand the best way to encode that. So some details on the implementation. We have functions for emitting these as well as macros. The functions is generally preferred. One of the main advantages is the name can be can be generated in the code. But you can also use the histograms as well. They should be used when you want to be very efficient. For example, if there's a tight loop and you emit a histogram many times within a very short period of time, since they're more efficient, we recommend using macros in those times. And just an example what this looks like, it's actually very, very simple in the code. This is a function version of an enumerated histogram. So the function call is UMA histogram enumeration. The first argument is just the name of the histogram. This is the tabbed on UTM histogram I described. And then you pass in what the event occurred. So imagine you're in the place in the code where someone clicks the new tab button. You add this line of code, and this is going to emit that value at that time. And so once you've actually added the code to emit the histogram, it's very important to add the XML description. So we have a set of XML files, histograms.xmls in the Chromium codebase. You can check them out, and these have big descriptions of all the different metrics we have. And so you should be adding this at the same time you're adding the emission of the metric. Note that there's the name of the histogram. If it's enumerated, you have to give the name of the enum. We have an expiry date, so to make sure we don't keep too many old histograms. And then there's description. Important things about the description, you should be describing very clearly what exactly is being recorded and be very clear on exactly when it's recorded. As well, if there's any caveats, they can be noted here as well. This way, anyone looking at data can have a clear description of what the metric is. And then at the bottom, you see I actually have the mapping from the enum values for the various enum buckets of the histogram. So here, the new tab button is the first one. That's what we just saw in the implementation slide. When you're adding a histogram, then you can do end-to-end local testing by using a debug page, going to chrome://histograms. This actually will let you show all the histograms that have been emitted since the browser started, so you can actually very easily check out how it's working. That's just in terms of local testing, but if you actually, and we recommend you should be doing unit testing as well, and we have some methods for that in base test metrics histogram tester. So that's a quick overview on how to add UMA histograms, and that concludes our talk. Thanks for listening. Hopefully you've learned a little bit about metrics, and I think I have some time for questions.